All right, can you see the screen?
Yeah.
All right, we did that. We did this related to the, no, I don't, this is not your lesson. I have sent I think I have sent the file to you, yeah? Related to chemical energetics. I'm
Yeah.
going, I'm going to stop the share just a minute. Yeah, the same note. I sent you the same note. Okay. Yeah. So we did this last time. I hope you can see the screen.
Yeah.
All right. So chemical energetics, we did this. I'm just scrolling it very slowly down. So can you please check the all the concepts which we have done? If some concept is not clear, you may ask, please. We talked about combustion, formation, neutralization. Then we did the definition, the equation. Same goes for combustion, the equation, and then neutralization, the reaction. Then I told you about the ionic equation, and then the calculation of heat of neutralization. So we did all of it. I hope it's clear.
Yeah.
Anything you want to ask, Beta, please do ask right now if you want to ask something.
No, it's fine.
All right, fine. So it was all related to the calculation of standard enthalpy change of neutralization, right? So we have done that. The next part of the topic is Hess's law. Yeah, okay. Hess's, sorry, Hess's law. All right. Any idea about Hess's law?
Mm,
All right. So, yeah, were you telling me something or should I proceed on?
you can proceed.
All right, fine. Okay, I was telling you about the Hess's law that Hess's law states that the reaction is the energy change of the reaction is independent of the path taken. Of the path taken. What does it mean? It means that whether the reaction is completed in a single step or it is the reaction is completed in multiple steps, the overall energy change would be the same. That is Hess's law. So according to the diagram, let's suppose your destination is point C. This is your destination. Now let's suppose you want to reach point C. One student, he takes a, let's suppose it's a school or college, right? One student, he first goes from A to B and then he goes from B to C. Another student, he goes directly from A to C. So in both the cases, what happens that the energy change remains the same. Now, Hess's law says that the energy change which takes place when you go from A to B and then from B to C, that would be the same if you go directly from A to C. So A to B and then B to C is equal to A to C. All right. So A plus B plus C is equal to A plus C. So this is called as the Hess's law. Now, if we talk in terms of direct route and indirect route, but always keep this thing in mind. This is a trick. Head and tail. Wherever head and tail combines, that is an indirect route. And where heads combine, this would be the direct route. So that means that A plus B, A to B, and then B to C is actually the indirect route. And going from A to C, going from A to C, that is the direct route. So I'm going to write direct route is equal to indirect route. Direct route is equal to indirect route. This is very important. What is the meaning of equal? That means whatever is the enthalpy change in the indirect route, that would be the same as the direct route. Is it clear?
Yeah.
Any confusion, Betty?
No.
All right, fine. We will do some questions. We are going to do some questions today. We will do some questions, inshallah, in the next lesson. All right, all the important questions related to chemical energetics, including MCQs and the theory questions. Now, if we talk delta H, as I told you about delta H, so when we talk about delta H, in we are going to calculate delta H, which is the enthalpy change. Now, whenever we calculate delta H, two types of data would be given to us. Two types of data would be given to us. Now, what two types of data will be given? I'll tell you in detail. Have a look. Just a minute, Vijay. Sorry for this noise. All right. So the data which would be given to us, it could be actually the data for enthalpy change of combustion or the data for enthalpy change of formation. So in the question, either of them would be given. We could be given enthalpy change of formation data to calculate the standard enthalpy change. Garam ho gaya abhi. And we could be given the standard enthalpy change of combustion data in order to calculate delta H. So now what I will write, it is going to bother you for a while, but when we will do the whole question, then it will be easier for you. Now I'll write another important thing, which is not given in the book. These are the tricks. As I told you earlier about the head and tail method, it is that wherever head and tail meet, it is called as the indirect route. Same is the case here, beta, that when you are given the data of combustion, the arrows go down. Now, when you are given the data of the formation, the arrows, they go up. How and why and what's the point of doing this? I'll tell you later. It's a shortcut. Now, have a look. Let's suppose we have been given the data for a question. I'm going to go to the data afterwards. First of all, let me tell you in terms of direct and indirect route. Let me tell you about the direct route and the indirect route through an example. For example, carbon. A student has been asked to make carbon dioxide and water. Now, the teacher gives this task to two students that you are supposed to make carbon dioxide and water, not experimentally, but theoretically. One student says that, Miss, I am going to combust carbon to get carbon dioxide, and I'm going to combust get hydrogen to get water. All right. So he's absolutely right. He combusted carbon to get carbon dioxide. The carbon plus oxygen definitely changes into carbon dioxide. Whenever I say combust, that means that use of oxygen. And he also combusts hydrogen to get water because when hydrogen reacts with oxygen, it forms water. I hope it makes sense, right? Now, another student, he does what? He says that now the first student has already made carbon dioxide and water through direct method. So he doesn't have this option. So what he says to his teacher is, Miss, I am going to combust carbon and hydrogen together to get pentane, and then I will combust pentane to get carbon dioxide and water. Now, beta, always keep this thing in your mind, beta, that whenever you combust carbon and hydrogen together, you get a hydrocarbon, which is called as alkane. All right. It's a hydrocarbon. And always keep this thing in your mind. Whenever you combust a hydrocarbon, you always get carbon dioxide and water. I hope it makes sense, Zena. Yeah, if anything is bothering you, please tell me.
No, it's fine.
All right. So this is now have a look. First of all, we are going to talk about the arrows. As I told you that for combustion, we use downward arrows. Have a look. This is a downward arrow. This is a downward arrow. This is a downward arrow. All right. So all these arrows are downward. So this is proven for combustion data because carbon is being combusted, hydrogen is combusted, and hydrocarbon, which is pentane, is combusted. The next thing, as I told you, I'm going to scroll up a little bit. I told you about the head and tail root. Now have a look at this and tell me if I'm going to write them as H1, H2, H3, and delta H. Can you please tell me which one would be the direct route and the indirect route? Hess law says that direct route is equal to indirect route. Can you tell me which one is in terms of H1, H2, delta H, which is the direct route and which is the indirect route, please?
Um, is a direct route where the two heads meet.
Where is it? Have a look.
Um,
Here, right? So that means, first of all, talk about the indirect route so that it will be clear. Can you see this head, Zena? This head, all right?
yeah,
And this is the tail. So that means that this head and this tail is the indirect route. Are you making sense of it, right? This is the indirect route. Yes, beta?
yeah,
So I'm going to write delta H plus H3 is the indirect route. So I will write it here, beta. Delta H plus H3 is the indirect route. Now have a look here. Head and again and head. So that means this plus this would be the direct route. Yes, Sena? So H1 plus H2 would be the direct route. Take your time, beta. If you have understood it clearly, it's fine. If not clear, then do tell me, I can explain again.
yes, fine.
The only thing you need to add is you need to multiply the H2 or H1 or H3 with the coefficient. Here, the coefficient is 1, so there is no need to multiply H3 by any number. But here the coefficient is 6, so we need to multiply H2 with 6, and the coefficient for carbon is 5, so we need to multiply H1 by 5. Is it clear?
Yeah,
Yeah. All right. Now I am giving you, beta, I'm giving you a question. You will make the equation on your own. Now, you know what? In the data, when I'm going to give you the question, this one will be given to you, this one will be given to you, and this one will be given to you. So you can easily calculate delta H. So this one is given, this one is given, this one is given, and delta H can be easily calculated. Yes or no, beta? Clear?
yeah,
All right, fine. So I'm going to give you a question, beta. I'll give you the values. Fine. Question is, find the enthalpy change for the reaction between carbon and hydrogen to make methane. Uh, take help from the following data. Take help from the following data. So the data is this in front of you. All right, so data is standard enthalpy change of combustions are given to you, and their value is given in kilojoule per mole. So this is delta HC of carbon, delta HC of hydrogen, delta HC of butane. The values are minus 394 kilojoule per mole. I have already written kilojoule per mole on the top, so I'm not going to write it every time. The standard enthalpy change of combustion of hydrogen is minus 286, and standard enthalpy change of combustion of butane is minus 2877. You need to calculate the enthalpy change of the reaction, that is delta H. Now, Bete, I'm going to keep this in front of you. You need to calculate it and tell me the answer, please. All right?
Okay.
All right. Now start doing it, Bete. I hope you are doing, Zena, right?
Yeah.
Do tell me when you are done, right, Zena?
Yeah.
But if you need help, do tell me, right? I can help you in solving the question. First of all, it's good to try on your own. If you are stuck somewhere, then do tell me. I'll help you.
Okay.
Yes, Zena?
Is the answer minus 89?
No, let's check it out. Uh, have you done it for, I'm sorry, I wrote methane here. Have you done it for butane? Have you
Oh,
done, have you done it for butane?
I did it
No?
for methane.
I'm so sorry. I forgot to write butane. I wrote methane. So maybe that's why you got the wrong answer. I'm so sorry. Can you do it again, Zena?
Yeah,
Sorry for the botheration, beta. You have to make the equation on your own.
yeah.
Zena, can you take a screenshot of the question so that I can incorporate some other questions from your notebook?
Yeah, okay.
Okay, good. Uh, I'm just going to stop the share for a while. Yes, Zena, are you done, beta?
Is the answer minus 126?
126. It's very close, but the answer I've got is minus 129. Check again. I'll also solve in front of you for butane. So for butane, this would be 4C plus 5H2 changes into C4H10. Am I right? Yeah. So now you are going to get what from this carbon dioxide and this water. This is the main equation. So it should be balanced. It should be balanced. It must be balanced. And then you are going to get water, and you are going to, when you will combust butane, still you are going to get carbon dioxide and water. So this is beta delta H. This is H1, this is H2, and this is H3. So what is the direct route and indirect route? Zena, can you write, uh, can you make me write down the equation, please?
Is the
So what is,
direct
yeah,
um 4C plus 5H2 equals C4H10?
So this means direct route is H1 plus H2. Yes? This plus this. Yeah? And the indirect route would be delta H plus H3. Am I right? Yeah?
Yeah.
What else do you need to do? The values have been given, but what will you do with the values
Do
for the
you
yeah?
do you add them up?
You will add them up, but there is an extra step which you need to do to get a correct answer. What is
Um,
that? Yeah.
multiply them by like 4 and 5.
Yeah. So if the coefficient for carbon is 4, then you need to multiply H1 by 4, whatever the value, right? And then you will multiply H2 by 5. Yes? Are you getting it? Yeah.
Yeah.
And what is the value for carbon? The combustion of carbon is minus 394. So that means 4 times minus 394. And what is the value for hydrogen? You can see here. The value of hydrogen is minus 286. And where is hydrogen given here? So whatever is the value, you need to multiply it by 5. So minus 286 should be multiplied by 5. I hope it makes sense, right?
Yeah.
So, should I write that under H1, should I write 4 into minus 394 plus 5 into minus 286 is equal to delta H plus and H3? Because the coefficient with butane is 1, so there is no need to multiply the value of H3. And what is H3? Combustion of butane, and the combustion of butane is minus 2877. So, this is equal to minus 2877. So add them up, beta. This would be minus 1576. This would be minus 1430 is equal to delta H plus minus 2877. Add them up. Minus minus would become plus. So that would be minus 3006 is equal to delta H plus minus 287. Now bring this value to this side. It would become minus 3006 plus 277. That would be equal to delta H. You need to calculate it. All right. So subtract them. It would become minus 3006 minus plus 2877. That would be minus 129 is equal to delta H. So the value of delta H would be minus 129 kilojoule per mole. Now see, beta, where have you made the mistake?
Uh, I guess mixed up the numbers a bit.
Okay. All right. So be very careful when you are copying them down, right? This question is clear, or should I explain you if something is not clear?
It's clear.
It's clear? All right, fine. So, Zena, going back to the main point that you need to calculate delta HC. When you calculate delta HC, you have been either given delta H, sorry, if you have to calculate the delta H, which is the enthalpy change. Whenever you need to calculate the enthalpy change, two types of data, one of the two types of data would be given to you. Maybe you are given with delta HC or delta HF. In this question, we have just solved, we have been given the data of delta HC, that is combustion data. Now, what happens if the data which is given to us is the formation data? Let's suppose we have been given the formation data. Now have a look. What did I write with formation? I wrote which type of arrow? Upwards or downwards arrow?
Upwards.
Upwards. So now have a look how to calculate the enthalpy change. This is Hess law. This drawing is called as Hess's law. Now I'll write when standard enthalpy change of formation data is given. So now when this data is given, what you need to do is, let's suppose, now this the column which would be given to us, or the data which would be given to us, would be of formation. First of all, we need to form the compound by the given equation. Now, the equation given to us is calcium carbonate, arrow, calcium oxide plus carbon dioxide. If you see that this is the decomposition reaction, that 1 mole of calcium carbonate decomposes into calcium oxide and carbon dioxide. We need to find delta H is equal to question mark. Now, the data given to us is like this. Let me show you how the data is given, and then you will tell me how can we solve this and this. Oh dear. No. One. So compound and delta HF in kilojoule per mole. Let me highlight this. This is delta HF. Now, let me write down the values. Calcium carbonate solid given minus 1207. Calcium oxide solid minus 635. Carbon dioxide gas minus 394. These are the values given to us, right? And the question says calculate delta H. Calculate delta H this. Now, I have been given the standard enthalpy change of formation. All right. Now I need to set this equation in such a way that I can use the standard enthalpy change of formation. This is the main equation given to us. I'm going to write it again. Have a look. Calcium carbonate. Uh, sorry. Calcium carbonate. I'll take it a little bit down. Just a minute, Peter. Yeah. So I have been given calcium carbonate changes into calcium oxide plus carbon dioxide. I'm simply copying this equation beta which has been given. All right. Now, because formation is given to me, so that means calcium carbonate needs to be formed, calcium oxide needs to be formed, and carbon dioxide needs to be formed. Always keep this thing in mind, Zena, that whatever is the main equation, it should be properly balanced. If you are not going to balance this equation, you will never get a correct answer. So this should be properly balanced. Now, after that, you need to form calcium carbonate, calcium oxide, and carbon dioxide. Which elements could be used to form all these three? Can you name those elements? If I want to form calcium carbonate, which elements should I use?
Calcium,
Yeah. What else?
carbon,
What
and
else?
no, 1.5 O2.
All right. There is no need to balance it because I need to make three things out of it. I need to make this calcium carbonate, carbon dioxide, and calcium oxide. So I cannot balance it up for each and everything because this is the main equation. So I will simply write down the elements. So this, I am repeating it again and again. This equation must be balanced. If this equation is not balanced, then you will never get a correct answer. If this is not balanced, it's okay, fine, right? So I will write calcium solid, carbon solid, and oxygen gas. So I am going to draw the arrows up like this arrow up. Now calcium and oxygen will combine to make calcium oxide, and and carbon and oxygen will make up carbon dioxide. All right, so these are the three arrows. Can you see that I have drawn the upward arrows now? Can you see that?
Yeah,
Yeah. And always keep this thing in mind, beta, you can't balance this because you need to balance it for all of them, which is not possible. So there is no need to balance these elements. However, you need to balance the main equation. And I'm going to scroll up quickly just to show you the other example uh, here. So you must have noticed that this is balanced. This is properly balanced. Carbon dioxide and water, look, I haven't balanced this. I have balanced this equation, which is the main equation. Does it make sense? Yeah.
yeah.
All right, fine. Good. So the values are given, beta. Now I'm going to write H1, H2, H3, and delta H. Now, can you use the arrows and the Hess's law? Indirect route is equal to direct route to make the first Hess's law, and then Hess's law has already, sorry, Hess's diagram has already been made. What you need to do is you need to calculate it, you need to equate it. Indirect root and direct root you have to make on your own. Or I can help you in making this. So what is the direct root in front of you, or indirect root? First indirect root. What is the indirect root?
Is it
Look for head and tail.
a H1 plus delta H?
Well done. So this is head and this is tail, right? Now, if you go to the other way, you will come to know this is head and this is also head, right? This is head and this is also head. So you can't go for this one. Are you getting my point? Because this is
Yeah.
head and this is head. This is head and this is head. However, this is head and this is tail. So, bete, this plus this is the indirect root. That means H1 plus delta H is the indirect root. And as I told you earlier, because we have a coefficient 1 here, so there is no need to multiply H1 by any number. There is a coefficient 1 here, so there is no need to multiply this number. And there is a coefficient 1 here, so there is no need to multiply the number. So I will simply write the indirect root would be H1 plus delta H. And what is the direct root, beta?
Is it um H1 plus H2?
No,
Wait.
no,
Oh,
Bachi. This is already done, Bachi. This is H1 is done. H1 plus delta H, this is the indirect root. Beta, you are done with this. So you can't use them again. So what you are going to do? Your H1 can't be used again. So what is the indirect root now?
is it where the two heads meet together? Delta H plus H2 plus H3?
This would be this. The H2 plus H3. H2 plus H3. Is it clear?
Yeah.
Uh, what is bothering you, Beta? I'll explain you again. H2 plus, look, H2 plus H3, not H2 plus H2 plus delta H. No. Delta H is in the opposite direction. It goes from this side to this side. You can't add this to it. All right. You can simply add H2 plus H3 is the direct root. Don't add plus delta H in it. Delta H has already been done. H1 plus delta H. It's done in the indirect root. Head plus tail. It's the indirect root. Head plus head is the direct root because all heads are meeting here. Yes, Zena? Should I explain again?
Yes, please.
All right. What do you want me to explain? That how we are going to get a direct route? Yeah. Have a look here.
Yeah.
But hey, where is the head? Look, these are the heads. Head, head, and head. Now this head is combining with what? This head is combining with what? Tail.
Yeah.
Yeah. So this plus this is the indirect root because I told you head plus tail is the indirect root. Yes or no? Head plus tail is the indirect root. Okay. Now the other one. Have a look. This is a head. This is a head. And this is a head. So that means these are the heads combining, right? This head and this head and this head. So because the heads are combining, so this plus this, these are the direct roots. However, this head and tail, this is the indirect root. Whenever a head and a tail combines, this is an indirect method. So head plus tail, this is the indirect root, right? And here is head plus head. So this is the direct root. And because H1 plus delta H has already been done, have a look here. H1 plus delta H. H1, which is this, and delta H, which is this. And we have already combined them, so that means delta H can't be used again. Delta H can be used only once. So what is left in direct root? Direct root is this plus this. H2 plus H3. Why? Because look, head and head. So that means it's a direct root. Head and head. That's the direct root. And this is head plus tail. That's the indirect root. Now tell me, Zena, should I explain again?
No, it makes sense now.
All right. If not clear, no problem, Zena. I can explain again. No problem.
No, it's fine.
All right. So what is the direct root now? Can you make me write down the direct root, please?
What did our group be? H2 plus H3?
Well done. Now you simply need to put the values. Put the values down. It's right there in front of you and get the answer. And please tell me the answer. What would be the answer?
What for the like the enthalpy change?
Yeah, delta H. Yes. This would be enthalpy change or standard enthalpy change of formation. You know what? This could be called as delta H or enthalpy change of formation. Why? Because 1 mole of calcium oxide and 1 mole of carbon dioxide has been formed. So this can be can be called as delta H or delta HF, one and the same thing. Yes.
Would it be is it 178?
Well done. Well done. So del shabash beta. Delta H is equal to plus 178 kilojoule per mole. I hope it's clear. Yes.
Yeah.
All right. Now, this is the question in front of you from your book. Uh, yeah, reaction below, solve the equations below or the reactions below using a thermochemical cycle. A, B, C, D, E is given to you. So the values are also given. Can you please solve it for zinc? D part. Can you do part D? Use the values of the full question is use the value of delta HF. Have a look. Sorry. Have a look. Delta HF is given. Yeah. Delta HF is given. Use the values of delta HF in the table to calculate delta H for each of the reaction below using a thermochemical cycle. Do part D.
Which one should I do?
Sorry.
Which questions should I do?
D. I told you part D.
Oh,
And keep this thing in your mind that you need to, you have been given standard enthalpy change of formation. So you know how to make the thermochemical cycle, right?
yeah.
Okay, good.
Is the answer 5?
5. Let's do it together. Zinc, Zn solid plus CuO solid plus ZnO solid plus Cu. You have done this question, right?
Yeah.
So formation is given. So what we can do is we can take zinc plus copper plus oxygen. These are the three elements, right? Yeah. So we are going to draw the arrows up like this. Does it make sense, Bache? That what I'm doing is zinc cannot be made. We do not have this because this we do not know about the formation of zinc. It's not given in the data because we do not know about the formation of the elements. It is always zero. All right. And copper oxide, yes, we can take the value, and zinc oxide, yes, we can take the value. And I haven't drawn any arrow here because the formation of copper is not known. So I'm going to rub this arrow as well. So there are only two arrows. That is copper and oxygen, they combine to make copper oxide, and zinc and oxygen, they combine to make zinc oxide, right? So this is the main thermochemical cycle which could be made. Now I will write H1 here and H2 here, and this is the main equation. It should be properly balanced, and it is balanced. They have given the equation to us in a balanced form. So now write direct root is equal to indirect root. Now this is, have a look better. This is head and this is tail. So can I write H1 plus delta H is as an indirect root, and this is head and this is also head. So H2 is the direct root. Does it make sense, Zain, or should I explain again?
It makes sense.
All right, so this is the head and this is tail. So that means H1 plus delta H is the indirect root. So under indirect root, I will write H1 plus delta H. And under direct root, there is only one arrow, that is zinc and oxygen. They combine with each other to make zinc oxide. Don't be confused with this arrow that I am extending the arrow from oxygen. It doesn't mean that only oxygen has been involved. It means zinc and oxygen, they are going to mix up to make zinc oxide. I hope it makes sense. So under direct route, I will simply write H2. Yes, Zena, is it all clear?
Yeah.
So let me put down the values. There is no coefficient with them, so there is no need to multiply it. Now H1 is what? Copper oxide. So what is the formation of copper oxide? Minus 157. So I will write bit minus 157 here. What is delta H? Not known. What is H2? Zinc oxide. So let's see, where is zinc oxide? Zinc oxide minus 348. So I will write minus 348. So take this to the side, it would become minus 348 plus 157 is equal to delta H, and delta H is minus 191 kilojoule per mole. So this is the answer. So what were you doing wrong, Zena? Hello,
I
Zena.
think I uh I think I just did it all of it wrong.
Okay. Solve it again, or it's better to solve another question. Any other question you can solve with it. Hmm?
Um,
Go for which one? You decide. A, B, C, E. Any one of them.
I'll do C.
Okay, C. All right. So the values are in front of you. Okay. Always, I'll write here delta HF. I will write delta HF of an element is always zero. Is always zero. We do not know how that element has been made. Only God knows how that element has been made.
Sensor minus 97.
Well done. Yes, the answer is minus 97. All right, good. Now this question. Or can you do it as a homework, Zaina? Because I have
Yeah.
got a next class scheduled up. So do this question as a homework, and I'm going to post a homework, another homework. So kindly do it till the next class, right? And we are going to do the past papers in the next class. However, this chapter is not fully finished. I still have to teach you about the bond energy, and then this chapter would be completed. But I am going to do the questions related to the topic which we have already done. All right. So in the next session, I'm going to try. I'll try to finish the remaining topic, but first we will do some past papers, right?
Yeah.
Okay, and do this as a homework question. Calculate delta H for the reaction by thermochemical cycle. So can you kindly tell me? Oh, all right, you need to use via HF values and via HC values. Both the values have been given. HF values have been given and HC value has been given. So you have to solve two questions, A and B, right?
Yeah.
Okay, so please do solve this question and some other questions which I'm going to post soon. Okay, thank you, Zena. I hope that you have understood the lesson properly, right?
Yeah.
Okay, thank you so much, Bete. Allah Hafiz.
I love this.